a square and a rectangle. All right. So rational exponents are exponents that are fractions, right? And I know what you're thinking. Ooh, fractions, Miss Hoy, don't do this to us. But I thought you said this was easy. It is. This is easy, easy stuff. Basically, what we're going to talk about is converting from exponential form to radical form, right? In the exponential form of something, that's not how you spell form. I would have, say, a raised to the 1 over n power, right? And if I want to convert that to radical form, I would write that as the index is n, so the denominator is the index, and the square root is a, the nth root is a. What does that look like in terms of numbers? If I had 2 to the 1/4, right, I would write that as the 4th root of 2, right? If I had x to the 1/8, that would be the 8th root of x. If I have x to the 1/2, we don't write the index, right? That's a square root. It just means the square root of x. Does that make some sense to you? So the next bit should make some sense as well. If I have, or we'll call it, I'm just going to call it x form now, the exponential form, expo. Instead of expo, we'll call it exfo, right? So if I have the exponential form of a to the power of m over n, notice here our numerator is just 1. Here our numerator is m. We would put that in radical form by saying the nth root of a to the power of m. So again, if this was like x to the 2/3, this would be the cube root of x squared. Denominator becomes our index. The numerator we raise to the power, right? If I have xy to the 2/3, right? Notice how I have this in parentheses, this 2/3, right? That parentheses means it applies to everything inside it. So then we could write this again as 3 to the xy squared. Pretty easy so far, pretty easy to follow, because it really doesn't get a whole lot more difficult than that, as long as you know how to break these down, right? So we'll do a bunch of different examples, and then I will set you free. I mean, literally, that's, yeah, you're just rewriting them in different forms. And you're going to go back and forth, right? If I had something, if I had this 3xy to the squared power, and I asked you to put it in exponential form, you would rewrite that as xy to the 2/3, right? So you're going to have to go back and forth with them. It's all in Delta Math too, so it's not like you have to show me a bunch of work. You just have to rewrite them correctly. So all I'm going to do a bunch of different examples so you can see every possible way I can imagine that these would go, or if you have to break them down, and then I'm gonna be done with you. First one, if I have k to the 7 halves, right? I'm gonna rewrite that as the square root. I could put the 2 there, but I don't have to. K to the 7th. Now this is one I want to show you, because if I have k to the 7th and I have an index of 2, that means for every 2 k's I could pull one out. So 7 divided by 2 is 3. So I'm going to have k cubed on the outside, but 2 times 3 is 6, so that means I have 1 k left over. Please let me know if you didn't follow what I just did, because I know that one I've actually reduced, but we've been reducing these things, so I'm hoping you were able to follow that. But please tell me if you didn't, so that I can explain it better. If I have, for example, 3 to the 5 fourths, when I rewrite that, I get the 4th root, 3 to the 5th. Well, this means I have 5 3s. I can pull 4 out, right? So that would be 3 to the 4th root of 3, right? I'd still have 1 left in there. Well, you have to reduce. I don't even know how many you'll have to. You do not get it? Think about, remember when if I have the square root of x squared, we could just rewrite that as x, right? Because x times x equals x squared. Does that part track? So if I have the square root of x cubed, I have 3 x's in there, right? For every 2, I can pull one out. So for that x squared, I could pull one out, but I would still have 1 x left underneath. Does that part also track? So the same thing is happening here with this 3, right? So I have 3 to the 5 fourths, right? And when I rewrite that, I have a 4th power, and I have 3 to the 5th. For every 4, because my index here is 4, I can pull 1 out. And what I'm saying is I have 5. So I don't know why I've got a 3 out in front. There shouldn't be a 3 out in front. Right? So technically every time, well, yeah, I'm confusing myself. I was already pulling that 3 out and putting it in front. So when I have 5 3s, for every 4 that I have, I can pull 1 out. So I'm going to lead with I've got 3. I'm going to pull that 3 out. But because I had 5 and I could only pull 4 out, I still have 1 left, right? So that's going to have to go back under. Was that a better explanation of it? Okay. I'll try and do a few more like that, just so that we can see. Did you follow it with the k too? Where here we had k to the 7 halves, and we wrote k. We had our index of 2, k to the 7th, right? Which meant that for every 2 k's, I could pull 1 out. So 7 divided by 2 is 3 with a remainder of 1, right? 2 times 3 is 6, but I'd still have 1 left. So I could pull out k cubed, but I still have 1 k left underneath. If I have, I'm going to change colors just for funsies. if I have AB to the 3/4, right? When I rewrite that, we're going to have the 4th power, and we're going to have AB cubed. I could break that down if I want. I could leave it like that, or I could rewrite it as, that's a 4. I know it looks ugly. A to the 3rd, B to the 3rd, right? Either way is fine. If I leave it like this, that's absolutely fine. I feel like it's kind of as tough as it gets. Oh, you might see something that goes like 7 to the 12x times 12x to the 1/2. Keep in mind, this raising it to the power of the 1/2 only applies to the 12x. So you would rewrite that as 7 times the square root of 12x, right? You don't even need to put it in parentheses because technically it's all under the square root. We're not raising it to anything. So keep that in mind. What's in the parentheses is the only thing we're raising to the 1/2 power, right? That 7, it doesn't apply to the 7. Sometimes, though, you're going to get it and you're going to have to go in the other direction. Sometimes you're going to get a problem where you get, say, the cube root of 16, right? And you're going to have to convert that, and you would have 16 to the 1/3. Or if I had trying to think, look at something, see if anything's more complicated than that. But really, that's about as tough as it gets. If I have, for example, the 4th root of k to the 5th power, we're going to write that as k to the 5/4. There's only one other thing I really wanted you to see, is if, I don't even know if your Delta Math has any problems like this, but I still wanted you to see it so you could understand. If I have, say, x to the 1/3 times x to the 4/3, remember, if we're multiplying exponents, we wind something with exponents, right? We add the exponents together. These luckily have the same denominator, so we would have x to the 5/3, right? When we add those exponents together. And so when we go to rewrite that, we would have the cube of x to the 5th. Again, I have more than 3 x's in there, right? I've got 5 of them. So I could pull out an x, and then I would still have 2 x's left. So you can possibly have to do something to them before you get there. I don't think any of your Delta Math problems actually have that. I think they're more geared towards that stuff we were doing at the very beginning there. Any questions about that? I told you it was a pretty straightforward assignment this time around. That's literally all I have for you today. I thought this was going to be a longer lesson when I put it together, and then I realized when I was teaching it last period that, this is way easier than I had anticipated it